All right. So today we're going to talk about understanding square root. I know you understand some things about square root. I apologize if any of this feels kind of babyish for you because you've known it for a long time, but want to make sure we cover all the bases. So here at the beginning, Nikita wants to use the area of the squares to find, in the figure right, to find the lengths of the sides of the triangle. So first of all, the missing area. The missing area is this part. What is this missing area? What's the area? 4 square units. So that missing area is 4 square units. What are the lengths of the legs? Remember that the legs are the two sides that form the right angle. So that means this side down here on bottom and this vertical side. So how long is the side on bottom? Tell me. 4, and
2.
This is 2. How do you know that? I'll take a volunteer for this. Yeah.
Finding the square root.
Yeah, we're just finding the square root. The square root of 16 is 4, and the square root of 4 is 2. Johnny, when you're thinking about finding the square root, do you just have all of them memorized, or what is it you're thinking about when you're finding the square root?
Which number can be multiplied by itself before that number?
That's exactly right. That's really well said. Whatever number multiplied times itself will give you the number that we want. So the lengths of those two are 2 and 4. So 2 units and 4 units. And that's because the square root of 16 is 4 and the square root of 4 is 2. Now, how long is the hypotenuse then? Pardon? Yeah, it's the square root of 20. Can you give an exact number for this? No. So the square root of 20, there is no exact number other than the square root of 20. The square root of 20 is the exact number, but you can't give a decimal or a fraction. There is no decimal, there is no fraction that when multiplied times itself will give you 20. There is no decimal or fraction that when multiplied times itself that will give us 20. So we're going to end up looking at 2 different kinds of numbers here. So the numbers 36, 64, 4, all those ones that are listed there are what are called perfect squares. If each of these numbers represents the number of square units in the area of a square, what is the side length for each one? So let's just write them underneath. For 36, what would the side length be? 6. For 64? 8. For 4? For 16? Yeah, we already did both of those. 100? 10. 144? What? 12? And 121? And do you know 225? That's 15. Okay. So why do you think those are called perfect squares? Well, they're called perfect squares because their square roots are whole numbers. But the square root of 20 is not a whole number. In fact, the square root of 20 is what's called an irrational number. That doesn't mean it's crazy, okay? But it does mean that there is no whole number or fraction or decimal that is exactly equal to the square root of 20. So you already know this. You guys have talked about it already. When you're trying to find the length of a square, or length of the side of a square, where you already know the area, you take the square root. You know what that symbol looks like. It's also sometimes called the radical sign. By the way, there are other roots besides square roots. No. That's a good guess. There are cube roots, which is the third root. Or you could have, like the fifth root. So with a square root, you're looking for what number multiplied times itself will give you that number. For a cube root, you're looking for what number multiplied times itself 3 times will give you that number. So for example, the cube root of 8 is 2, because 2 times 2 is 4, times 2 is 8. And you can do this for any number. You may be wondering, why in the world all these other ones have this little number here, which is called the root index. It's not important that you remember that right now. Why isn't there one here? And yeah, the simple answer is because mathematicians are lazy. At one point, I'm sure that everyone wrote a 2 there to indicate that it was the second root. You needed 2 numbers multiplied together to give you that number. But at some point, they also went, that's the most common one, and I'm tired of writing that little 2. Let's all agree to stop. And they did. Okay? And you can say, that was a good job being efficient, or man, you guys are lazy. Depends on your point of view. So to find the length of a side of a square with area of 81, you would write the square root of 81, and since 9 times 9 is 81, the square root of 81 is 9. All right, moving on. I think most of you will do this extremely quickly. Rewrite each square root as an equivalent expression without the radical sign. Explain your method for finding the square root of these numbers. So for this first one, square root of 49 is 7, because
7 times 7 equals 49.
exactly right. That's the explanation part. You can do these other 3 very quickly. Go. Be sure to write your explanations as well. All right, square root of 121 is 11, because 11 times 11 is 121. Square root of 9 is 3, because 3 times 3 is 9. Square root of 169 is 13. Because 13 times 13 is 169. All right, let's move on. Between which two whole numbers is each of the following square roots? So like the square root of 40, we don't know exactly what that is, but you should be able to say, well, it's between this whole number and that whole number. Let me explain to you how we're going to do this. What you need to do is think of a perfect square that's a little bit less than 40 and another perfect square that's a little bit more than 40. So what's a perfect square that's a little bit less than 40? 36. That's less than, the square root of 36 then is less than 40. And what's a perfect square that's a little bit more than 40? 49. So the square root of 40 is between 6 and 7. Which one do you think it would be closer to? It's probably closer to 6. It said it wants us to estimate the value of the close to the nearest tenth. So what do you think? It's probably closer to 6 than 7. And I am asking for your best guess. About 6.3? 39.669, which is pretty close. Yeah. Okay, if you had guessed 6.4, I would have been, okay. If you guessed 6.2, I'd have been like, If you guessed 6.1, I'm going to be like, no, you need to do a better guess than that. All right? All right, so let's look at this, the square root of 95. What two perfect squares is that in between? 81 and 100. So the square root of 81 is between 9 and 10, exactly. Which one does it appear to be closer to? 10. And without working anything out, again, we're just taking a guess here. What do you think? Just take a shot. Don't work anything out. Just
9.8.
okay. I don't know what it is. Is 9.7 better? If you gave me either of those, I'd be happy. All right, see if you can do the next one on your own, please. All right, check your neighbors, make sure they're not wrong. All right. So, Cooper, what'd you get this one to be between?
7.
Between 7 and 8? Anyone disagree with that? All right, I'll take a volunteer for this. About how much is this? Yeah,
7.8.
7.8? Okay, I actually know a way to do, to get an approximation, but it's a fraction instead of a decimal. Since we have time, let me just show you real quickly. So, 7 times 7 is 49, right? Okay. To get from, so if we had a 7 by 7 square, that would be 49, right? And then what you can do is go, okay, if we wanted to start filling in what's next, where this would be 7 and 7, this would be 8 across and 8 up, right? We would fill it from 49 to 59, we have 10 more squares. So we can fill that in. So it would be this one and then 7 more over here. It would be all of those. And the total number of squares you would have on this outside would be 8 plus 7, because one of them is in both. So that'd be 15. So 7 and 10/15, which is 7 2/3, which is a little bit less than 7.7, because that's 0.6 repeating. So it's probably closer to 7.7 than it is to 7.8. You don't have to use this. It's just this. It's kind of a cool little thing. And it, you can use guess and check for that, but you don't have to. All right, square root of 200 is between what and what? 14 and 15? It's a lot closer to 14 than it is to 15, isn't it? I would guess, what do you think? 14.1, 14.2? I would think like 14.1. Again, if you gave 14.2 for that, I'd be okay with it. All right, page 3. All right, so you're going to complete this table for the side lengths and the areas. So, for example, if the side length is 1, its area is 0, the area is 0. If every side of the square is 1, what's the area? 1. If the side lengths are 2, what's the area? 4. If the side lengths are 3, the area is 9. For 4, 16. If the area is 24, what are the side lengths? Exactly. It's the square root of 24. How much is that? I don't know. It's somewhere between 4 and 5, though. What is it really close to? 5. Because the square root of 25 would be 5. If the side lengths are 5, the area of the square would be 25. The side lengths are 6. The area would be 36. I'm going to have to make this smaller. So I want you to plot those points. So 0, 0, 1, 1, 2, 4, 3, 9, 4 is 16. 5 is way up here at 25. And 6 is 36. Uh-oh, I hate it when I hit that little button. And you want to try and hit all those dots and make this as smooth as possible. Should look something like that. This is half of a parabola. You'll study parabolas more next year. All right, and then it says use your graph to estimate the following square roots to the nearest tenth. So when we're here at 10, if the area is 10, this is between 3 and 4, and each one of these is a third. So it's a little less than 3 1/3. So I don't know, I'm gonna say 3.3. Más o menos. Square root of 13. Let's see, 10, 11, 12, 13 is right here. So that looks to me like it's about 3.6. Square root of 28. It's right there. And again, we're estimating that, so I got to come all the way down to here. That is really difficult to do when you're trying to look at this on the screen. Yeah, a little less than 5.3. I'm going to say 5.2. And then the square root of 32 is here, and that's about 5.6, 5.7. We'll say 5.7 approximately. All right, we're not going to do the calculator part.